Hello students. In previous video we have discussed about law of conservation of linear momentum and how it can be derived by the help of Newton's second law and third law of motion that we have done earlier. Now in this video we are going to discuss how we can derive Newton's third law of motion using law of conservation of linear momentum. So we'll start with conservation law of linear momentum and ends at Newton's third law of motion. For this, let us consider two objects, capital A and capital B, with masses m1 and m2 respectively. So we are assuming two bodies, body A of mass m1 and body B of mass m2, and these are moving along a straight line, and colliding against each other. Since the body A and B are colliding, so their velocities are changing, and if velocity changes, their momentum will also change. Because of the collision, velocity is changing, and since velocity is changing, momenta will change for both the objects, and the change in momentum individually for both the objects, let this change be delta p1 and delta p2. So we are assuming that delta p1 is the change in momentum of A. That means this is the difference of momentum of object A before collision and after collision. Similarly, delta P2 is the change in momentum of object B in time delta t. So this is happening in time delta t. Now according to the law of conservation of linear momentum, we know that the linear momentum before collision must be equal to the linear momentum after collision, or the net change in linear momentum in the absence of external force should be 0. So according to this law, what we have, the net change in linear momentum when there is no external force, so in absence of external force, this value is 0. So here we have two momenta, delta p1 and delta p2. So the delta p1 is for the change in momentum of object A and delta p2 is for the change in momentum of object B. So the net change that we have in the momentum is delta p1 plus delta p2, and according to this law, this net change in linear momentum, that is delta p1 plus delta p2, should be 0. So according to the law of conservation of linear momentum, the sum of these two changes in momentum will be 0, which implies delta p2 is equal to minus delta p1, or we can also write from this delta p2 over delta t is equal to minus delta p1 over delta t, where delta t is the time in which this change is taking place at the time of collision. So now left side is representing the rate of change of momentum of object B, and right side represented negative sign with rate of change of momentum of object A. So it shows that rate of change of momentum of object B is equal to negative rate of change of momentum of object A. Since this rate of change of momentum are equal and opposite, so we know that from Newton's second law of motion that rate of change of momentum is actually equal to the force applied. That means this is equal to force applied on B, on object B, and this is equal to negative of force applied on capital A, object capital A. Now this is action. If this is action, then this is reaction during the collision. Both bodies are applying force on each other in opposite direction. That means this is action, then this is negative sign, and this force will represent reaction. So for every action there is equal and opposite reaction. Equal and negative sign shows opposite. This proves that Newton's third law is valid. So since action is equal to negative of reaction, hence third law is proved here, right? Force, both bodies A and B are applying force on each other. So force on B is equal to the negative force on A, and these forces are applied by each other. B apply कर रहा है A पर, A apply कर रहा है B पर. That means if this is action, then this force is reaction, and these are equal and opposite to each other, and this is the third law of motion. So we can easily prove law of Newton's third law of motion by using law of conservation of linear momentum. So that's it for the video. For further videos, stay tuned and keep studying. Thank you.